Hi, so this week we are going to work on absolute value inequalities. Sorry about that. All right, so we have two cases. So we have greater than or equal to. That's case one. And case two is when you have the less than or equal to. So we have two cases here that we have to think about right now. So in this case, there's an absolute value. Remember, absolute value is when it's the distance between zero and that number. So absolute value is always positive. So as an example, because it's distance. So the absolute value of -5 equals 5. And the absolute value of 5 equals 5, right? It's the distance between, since the units, from 0 to that number. So now we're dealing with absolute value inequalities, okay? So this has two cases. Remember when we did absolute value equations, it has two cases. So the first case is x is greater than or equal to 5. And the other case is x is less than or equal to -5. So notice that they're both cases, they're different in the symbols, right? The signs and the inequality symbols, right? So we have to flip them and then we use a -5, right? So they're the total opposites, okay? So it's gonna look, so this number one case, greater than, is gonna look like an or a graph, okay? So it's gonna go in both directions. So we find this is, they both have equals, so we're gonna find 5, and then it has a closed circle and it goes all the way to infinity. And then we have to find -5. It has a closed circle because they have an equal sign, and then it goes to positive infinity. And then if we remember how to do the interval notation, it's parentheses and negative infinity, it goes all the way to -5 and it's included, or we have starts at 5 and it's included because it has an equal sign, comma, and then infinity to the infinity. So case one, greater than, looks like an or, right? And case two, guess what? It's gonna look like an and, right? Yep. And then it's gonna go both ways also. So in this case, is x is less than or equal to 8, and then x is greater than or equal to -8. So notice that this flips the symbol and flips the sign of the number. And then this is gonna look like an and where it connects. So we find 8. They both have equal sign, so it's all both included, and -8, which is over here, and then we connect the graphs, okay? And then if we remember how to do the interval notation, well, because x is in between -8 and 8, and they're both included, we just write them like this, okay? All right, so notice that it's greater than or equal to, and then less than, or, so in this one, it's gonna be greater than, right? So it's this one, and then this one. And then this one would be what? Like that and like that, right? All right, so case one and case two. So what does this mean? Well, absolute value inequalities are really compound inequalities, right? Compound. And then, so less than or equal, it's an and greater than is an or. Okay, I'll just put it like that really quick. All right, so there are steps here to solve the inequality. So it says isolate the absolute value expression, create two cases, use the KISS method. I'll show you what that means. Keep it switch to set up the two cases. So you kind of combine, separate them and do them. solve both inequalities, graph the solution, and write the answer in interval notation. So those are the steps to solve an inequality. So let's do a couple here. I'm gonna do, we did already 1 and 2 on the top. It's very, very similar, but I'm gonna do 3 and 4 here. So in 3 and 4, we're gonna do both cases, right? So we're gonna do both cases, right? So the first case is gonna be x minus 1 is greater than or equal to 6. And then we have x minus 1 is less than or equal to negative 6. So let's do that. So plus 1, that goes away, and I have x is greater than 7. Or I have plus 1, that goes away, and I have x is less than negative 5. Okay, so this is, so we're gonna be using 7, so it's in between 7 and negative 5, right? So negative 5 is over here, and it's open. And 7 is over here, and it's open because it doesn't have an equal sign. Okay, so it starts at negative 5, and it ends at 7. Okay. All right, so this was like case 2. All right, so then let's do one for one that has more stuff here, like something like this. Okay. All right, so let's do that. So we're gonna get rid of anything that's out. We're isolating the absolute value first. So let's do that. So plus 1, that goes away here, and I have the absolute value of x plus 3 is less than 6. Now, once I have that, I can make my 2 cases. So that's x plus 3 is less than 6. And then I have x plus 3 is greater than negative 6. Then I solve. Minus 3, that goes away. And then I have x is less than 3. And then minus 3, that goes away, and I have x is greater than negative 9. And then at this point, I graph them. So I have both ways, right? So this is a less than, so it's gonna be connected. So I'm gonna go, my x is gonna be between negative 9 and 3. So negative 9 is over here, doesn't have an equal sign, and positive 3 is over here, doesn't have an equal sign, and they get connected. And then because it doesn't have an equal sign, I use parentheses, so x is between negative 9 and 3. Parentheses, and I'm done. Okay. All right, let's do another one. So what about something like this? Remember, this is multiplication. So to get rid of that 3, I gotta isolate whatever it has, whatever I have inside the absolute value here. So I gotta get rid of it by doing the opposite operation. This is multiplying, so I'm gonna get rid of it by dividing 3 in both sides. So then I have the absolute value of 2x plus 8 is greater than or equal to, well, that's 10. And then now once I get to this point, I can do both of my cases, right? So I have 2x plus 8 is greater than or equal to 10, right? That's 1. Or well, this is greater than, so this is an or. I have 2x plus 8 is less than or equal to negative 10. And then I solve. Minus 8, that goes away. I have 2x is greater than or equal to 2. And then my right here is x is greater than 1, right? Because 2 divided by 2 is 1. And then my other case would be -8, -8. That goes away, and I have 2x is less than or equal to -18. And then I divide by 2, and x is less than or equal to -9. Now, because this is a greater than situation, this is an or. So it goes separated, right? So then x is greater than 1. So I find 1. It's right here. It's a closed thing because it has an equal sign, a closed dot, and then it's greater than. And then I have 9, -9. -9 is over here, it's closed, and it goes this way. And I am done. So remember, one of the things that we have to remember here is look at those cases in the right here. So if it starts with this, a greater than or equal to, or greater than, then is case 1, which it looks like the or ones, where it goes different directions. If it starts with the less than or less than or equal to, then it's connected. Okay. So use your notes, guys. All right. I hope this helps. Come and see me for help.